I wanted to provide you with some information about the Math 1113 final exam. First of all, the final exam for Math 1113 is not proctored, which means you do not need to schedule a testing appointment. However, you do need to make plans to take it during the scheduled exam window and the dates you see there at the top of the page. You can, since it's not proctored, you may use your notes and other course materials. You may not use any other individual or a tutor or something like that. The challenge you may have if you're using notes and course materials, you want to have them organized because you are limited to 2 hours to take the final exam. It does cover the entire course, units 1 through 8. There are 9 questions on the exam from units 1 through 4 and 11 questions from units 5 through 8, which is a total of 20 questions. 9 of those questions are multiple choice, and 11 questions are fill in the blank. And I would strongly encourage you to read the questions carefully and pay attention to how you're supposed to round, if you're supposed to round, or are you supposed to leave it in terms of pi and that sort of thing. So please read carefully. There is a formula sheet that's provided at the beginning of the test, and it's also within the content of the course. You may want to have a copy of that handy while you're taking the exam, so you may want to print yourself a copy before you actually start the exam. There is a required Math 1113 final exam review that's in Newton. It is 5% of your overall course grade, so you do need to complete that. But I've actually looked at the final exam and kind of gotten an idea of the questions that you'll see, and so I've created some that are similar to those that will appear on the final exam, and this would be a great resource for you to study for the Math 1113 final exam. And so I'm going to go through a couple of these and work through them. The first one says find the vertical asymptotes for, and it gives you the function 100x times the quantity x minus 4 divided by the quantity x squared minus 16 times the quantity 2x plus 3 times the quantity x minus 5. You had a problem similar to this on the midterm exam, and quite honestly, a lot of you missed it. One of the first things that you need to do when you have a rational function such as you have here is you do need to simplify the rational function first. And in this case, that is going to require that you do at least a little bit of factoring within the denominator, because the quantity x squared minus 16 will factor. So I'm still going to have in the numerator 100x times x minus 4. I'm going to factor x squared minus 16. It is the difference of two squares. I would have x times x to get x squared, 4 times 4 to get 16. One is positive, one is negative. And I still have the quantity 2x plus 3 in the denominator and x minus 5 in the denominator. But then what I notice is that I have the same quantity x minus 4 in the numerator and the denominator. So they will divide out. So you don't have a vertical asymptote at the value x equals 4. It's actually called a point of discontinuity. It's just a single individual point. You cannot use the value x equals 4. So it's not an asymptote, but a point of discontinuity. So you don't need to select 4 as an option. But that does leave 3 other quantities in the denominator, and we know that the vertical asymptotes occur where those quantities are equal to 0, because you cannot have 0 in the denominator of a fraction. So we have x plus 4 equals 0, 2x plus 3 equals 0, and x minus 5 equals 0. And I'm going to solve each of those respectively for x. It doesn't matter where I start, so I'm going to add 5 to each side. So x equals 5 is one of the vertical asymptotes. If I solve x plus 4, I'm going to subtract 4 from either side. So I have x equals negative 4. That is a second vertical asymptote. And then I need to solve 2x plus 3 equals 0. So I'm going to subtract 3 from either side. So I have 2x equals negative 3. And then going to divide both sides by 2. So I have x equals negative 3 halves, and that is the third vertical asymptote. Again, you do not have a vertical asymptote at positive 4. It's what we call a point of discontinuity because you have to simplify the rational expression first. Question number 2 asks you to find the y-intercept for the rational function 5x squared minus 3x plus 5 divided by the quantity x squared minus 10. Okay, to find the y-intercept for any function, we simply let x equal 0 and we solve for y. So to find the y-intercept, we let x equal 0 and solve. So if I do that in this problem, if I substitute 0 wherever there's an x, I would have 5 times 0 squared minus 3 times 0 plus 5, all divided by 0 squared minus 10. Now, if you do the math out, okay, you can use your calculator. Calculator will do it for you, okay, but we would have 5, sorry about that. You would have 5 times 0, 0 squared, following order of operations. We would do the exponents first. So we would have 5 times 0 minus 3 times 0 plus 5 all over 0 minus 10. And again, if you continue with those calculations, it's probably just as easy to go ahead and put it into your calculator. Okay, 5 times 0 would be 0 minus 3 times 0 is 0 plus 5. 0 minus 10 in the denominator is negative 10. So we have 0 minus 0 plus 5. It's going to give me 5 divided by negative 10. The answer is a fraction, so be extra careful. Okay, make sure you simplify the fraction and watch your sign. 5/10 will simplify to 1 over 2, and it needs to be negative. And normally you'll see that negative sign written in the numerator as opposed to the denominator. Question number 3 is another question related to the rational functions, and it asks you to find the horizontal asymptotes. Well, to define the horizontal asymptotes, you need to first remember how to decide whether or not you have a horizontal asymptote. If you'll recall, there are 3 rules. You have to compare, you want to compare the degree of the numerator to the degree of the denominator. Remember, the degree is the highest exponent. So in this problem, the numerator, the degree is 2. That's the highest exponent. For the denominator, the degree is also 2. There are 3 rules, and if you'll remember the 3 rules, if the numerator is less than the denominator, there is a horizontal asymptote at y equals 0. If the numerator equals the denominator, there is a horizontal asymptote at y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. If the numerator is greater than the denominator, there is no horizontal asymptote. So if I'm thinking about the problem that I have or the problem that I'm given, I notice that the degree of my numerator is the same as the degree of the denominator. So I have the second scenario. So my horizontal asymptote is going to be y equals the leading coefficient is the number in front of the squared term in both the numerator and denominator, which would be 9 over -7. Be careful and don't lose your sign. So the horizontal asymptote is y equals 9 over -7. Again, we normally would put the negative in the numerator. Question 4 asks you to find the inverse f to the -1 of x for the function 2x minus 3 over 4x minus 5. And if you'll recall the process for finding the inverse of a function, the first thing we do is remember that this function, this is our function. Sorry about that. Okay, that function, and it is actually equal to y. And the first step to find the inverse is to interchange the values or interchange x and y. So wherever there's an x, we're going to put a y, and wherever there's a y, we're going to put an x. So if I rewrite this, I would have 2y minus 3 over 4y minus 5 equals x, and I'm going to make it a fraction by putting it over 1. And then because basically I have a fraction equal to a fraction, which in mathematics is called a ratio, we're going to cross multiply. So I have 2y minus 3 times 1 equals 4y minus 5 times x. And then on both sides of the equal sign, I'm going to use the distributive property so that I have 2y minus 3 equals 4xy minus 5x. And then I notice I have pieces that have y's on both sides. And so I want to get them together using the basic rules for combining terms. So I'm going to subtract 4xy, subtract 4xy, so that I have 2y minus 4xy minus 3 equals minus 5x. Then I need to add 3 to either side. So I have 2y minus 4xy equals 3 minus 5x. Then I notice that on the left side, both terms have a y. So I'm going to factor out the y. And if I do that, I have y times 2 minus 4x equals 3 minus 5x. And again, remember, ultimately, I'm trying to solve for y. So I'm going to divide both sides by the quantity 2 minus 4x So we have y equals 3 minus 5x over 2 minus 4x. Okay, and that actually equals F inverse, which is what you were looking for. Now, you have to be careful because there's various ways that you could write this particular expression by flipping it around and that kind of stuff. So just be careful. I believe that question is multiple choice, and so what you have written may not be exactly what's there. All right, number 5 says y varies inversely as the cube root of x. If x is 27 and when y is 5, find the value of y when x is 125. Well, when you start thinking about it, this phrase inversely, okay, tells me that kind of the formula that I need to use, okay, and that may be something that you want to go back and look at, but the formula is y equals k over a generic x. Now, specifically for this problem, if we use the terminology, it says y varies inversely as the cube root of x. And the first thing that I have to do is figure out the value of k. And so it tells me x is 27 and y is 5. So if I plug that into my function, I have 5 equals k over the cube root of 27. The cube root of 27 happens to be 3, so that's 5 equals k divided by 3. I'm going to multiply both sides by 3, so k is 15, which gives me the formula, if you want to think about it that way, of y equals 15 over the cube root of x. That's the generic formula. And so then it says, well, okay, what is it when x is 125? So now that we know k, we can go back and we can figure the value of y. So we want to find y, k is 15, and we're given the value of x as 125. So y equals 15. The cube root of 125 is 5, so y is 3. So ultimately, the answer, it's a two-step process because you have to find the value for your constant of variation, which is k, and then use that formula to solve the equation. All right, I want to try to do one more, and then we'll stop and I'll pick up on a separate video. This one says, find the x coordinate of the vertex of f of x equals negative 0.4 plus 14x minus 12. Okay, so hopefully you recognize this as a quadratic. And within a quadratic, remember that a is the number in front of the square term, b is the constant, b is in front of the x, and c is the constant. And it's a formula to find the vertex, and you only want the x coordinate of the vertex, and the formula is the opposite of b over 2a for the x. And so it's basically a plug and chug if I know that particular formula. Okay, so I want the opposite of 14 divided by 2 times negative 4/10. Okay, so I have negative 14 divided by negative 8/10. Okay, so remember, a negative divided by a negative is definitely going to be a positive. And when you do that division using your calculator, negative 14 divided by negative 8/10, you get a value of 17.5. And that would actually be the answer to the question. I want to go ahead, though, and find the y value of that coordinate, just in case you may be asked that on the final exam. To find the y value, we then substitute the x value, which we found to be 17.5, into the original problem. So I have negative 4/10 times 17.5 squared plus 14 times 17.5 minus 12. And again, it's a basic plug and chug, guys. And I think I have a calculator on my computer now that I can pull up, or at least I thought I did. No, looks like it's disappeared again. Okay, so I'm going to do it on my handheld. Okay, so we go, just type straight in like you see it. Negative 0.4 times 17.5 squared plus 14 times 17.5 minus 12. Just straight plug and chug. And when you do those calculations, you get a value of 110.5. And that would be the y value or the y coordinate of your vertex. You weren't asked for that, but in case you might see that on the final, and so that way you'll be familiar with how to do that. Okay, so this is questions 1 through 6, similar to what you'll see on the final for Math 11-13. We'll pick back up and look at some of the others in a separate video.